Okay guys, in this section we're going to talk about ions. So ions are ionic compounds with things that have a positive and negative charge, and they're held together by electrostatic attraction to each other. So this is an example of an ionic compound. Pyrite is fool's gold, and it has one iron and two sulfurs put together in an ionic compound. So we're going to understand how ions are made and how we have ionic compounds in this section. So let's remember what valence electrons are. They're in the outermost shell of the atom, and remember that the group number tells us how many valence electrons are in each atom. So they're in the highest occupied energy level, and these valence electrons are really, really important, and they tell us how chemicals react. So to find the number of valence electrons, we have to have this skill. It's very important. We have to look at where they are on the periodic table. So these elements here are in group 4A, and so they're going to have 4 valence electrons. So this is showing you what the structures look like based on their group numbers. So this is group 1, the alkali metals. They all have 1 electron in their outermost shell. So we show them like that. We're just caring about the electrons in the outermost shell. And these are the reactive electrons. Group 2 has 2 dots. They have 2 electrons in them. 3A has 3, 4, 5, 6, 7, 8. Those numbers of the representative, the A elements, those are the only ones we're talking about here. The ones that have A at the top on the periodic table, those are the valence electrons, and they're very important, and we have to be able to draw these things. Okay? So when you draw them, make sure you draw them with like this is like a square. So put 2 dots here on this line, 2 dots there, just like we see them here. Don't draw them any other way because it's going to help us when we're bonding later on. So draw them just like this, where you're assuming like this is a line, and you're going to put 2 dots on it, 1 or 2 dots on it, 1 or 2 dots here on this line, that line, that line. So draw them like this is a square. Help us with bonding later. So which atoms tend to gain and which tend to lose electrons? This is the octet rule. This is very important. This professor, I think he was at UC Berkeley, figured out that this is a nice way to draw these things. And he found that noble gases did not want to react. These are the ones in group 8A, because they already had filled shells. And so he explained this with the rule called the octet rule. So these elements that have a filled outer shell do not want to react. So all the noble gases on group 8A do not want to react because they have a full shell. This is really important. So atoms of metals are on the left side of the periodic table, and they tend to lose their electrons. And elements on the right side of the table, the non-metals, tend to gain electrons. And so let's talk about cations and anions. Cations are positive ions. And an atom's loss of valence electrons makes a cation. So if you lose, you become a cation. And you are positively charged because you're losing negative electrons. Cations are formed in metals. And we need to be able to understand what's going on here. So this is an important slide. So sodium, this is its electron configuration normally. It's in group 1, so it has 1 valence electron in the third shell. So this is in period 3, sodium. Look at your periodic table so you see. It's in period 3, and it's in group 1, so it has 1 valence electron in the third shell. It's going to lose 1 electron because then it will feel like it has a full octet. So then the second shell is totally filled with 8 electrons. So 2 plus 6 makes 8. This is an octet. So that's why sodium loses 1 electron, and when it does, it looks like this. It's a cation with 1 positive charge because it lost 1 negative. So the protons and the electrons are not balanced anymore like it was here. It's lost 1 negative charge, so now it's a positive 1. So some people have a little trouble with that. Make sure you can understand the balance between protons and electrons to figure out the charge. So the configuration of sodium is the same as neon, and that's what it wants to do. It wants to have that full octet. So here we go. We've got 2 in the first shell, we've got 2 in the 2s, we've got 6 in the 2p. If it loses this 3s1 guy, it would be really happy. It would be like neon. So here we got the loss of 1 valence electron. And now this guy feels like he's the same thing as neon, and he's so happy with that. So that's the way sodium reacts. It wants to lose this 1 valence electron. And then this configuration is the same configuration as neon, so it's happy that way. Very important. This is the foundation of a lot of stuff we're going to talk about this in this class. And so neon looks like that. So they're very similar. Remember, the nucleus is going to be different, but the electron structure is going to be the same. Very important that now sodium feels like neon. So we write it like this. We can write it like this as well, with 1 dot, because sodium's in group 1. It loses 1. It becomes Na+, with 1 electron as well. So we see sodium in the vapor light you see outside at nighttime. If you see that yellowish color, that's sodium being vaporized and forming cations. Magnesium can do the same thing. It's in group 2, so it has 2 valence electrons. It wants to lose both and become a +2 ion because it's in group 2, and it loses 2 electrons. Same idea as sodium, but now it has 2 outside electrons. So magnesium's good for our health and saving elements. So group 1 elements are going to lose a 1 electron. They're going to have a +1 charge when they're done. Group 2 is going to have a +2 charge when it's done losing 2 electrons. So this is something we have to memorize. Group 1A is a +1. Group 2A is a +2. Very important. So other elements can form ions as well. And so this one, it looks pretty full, right? Everything's full here, but it's got this one lone S, and if it loses that, it would feel more stable. So remember, all elements want to feel stable. So if it loses 1, it would lose that 1 right there, and then it feels more stable this way. This is all filled up. It's happy with that situation. Everything else is filled up. So these oddball ones are not as, when it has an oddball one, it doesn't feel as stable as if it could lose it. So after it loses 1 electron, it becomes +1. So this is copper 1 because it has a +1. This Roman numeral 1 means +1 right there. How are anions made? So we talked about cations just now. Let's talk about anions. Anions are formed when you gain electrons. When an atom gains an electron, so these are going to happen on the right side of the periodic table. So we're going to form a negative charge. It could be one atom, it can be a group of atoms with a negative charge. So when we make this, when it becomes a negatively charged ion, we call it an anion, and we give it the name ide. Like sodium fluoride is in your toothpaste. The ide is for the fluorine that changed to a fluoride when it became a -1. So these 5, 6, and 7A elements, they lose electrons. So 5, if it gets 3 more electrons, it's going to be filled with 8 electrons. This octet will be filled. 6, 2 more to have the 8 filling of its octet. It's 1. So these guys really are super reactive, especially fluorine wants to grab 1 electron from somebody. And these are all going to be nitride, oxide, fluoride. We're going to change the ending to an ide. So here's what's happening. We've got chlorine. It's got 2 in here and 5 there, so that's 7. It wants 1 more. When it does, it gets 1 electron, so it becomes a -1, and it's got a filled octet. And it's going to seem like it's like argon, so it's going to be happy that way, stable. So chlorine has this one lone guy right here. It would love to fill this little square up. If it gets 1 electron, it's going to look like that. It's going to be all filled up. S and P is going to be filled up, so that's an octet. And there is what argon looks like. So chloride looks very similar to argon. All of the electrons are filled and the octets filled, so it's so happy and stable. So this is, we can draw it this way as well. We can have chlorine with 7, gets 1 electron, becomes chloride, a -1 charge. So this chloride's huge amounts of this are in the ocean. Chlorine became chloride, and it's an anion swimming around in the ocean. So these become halides. Halogens, group 7A, are going to turn from halogens into halides when they gain their electron. Halogens have 7 valence electrons. When they gain 1 more, they become like noble gases. Group 6A is going to have 6 valence electrons, and it's going to want 2 more. It's going to want to fill these 2 holes right there. So it gains 2, becomes oxide, and it's similar to neon that way, and it's stable. So it looks like that. So we're going to learn how to draw all this stuff here. So here's some ions, and I need you guys to memorize these. This is going to help make your life so much easier, and you're going to get such high grades if you can go ahead and make flashcards or figure out a way to memorize these. You're going to use them in this class and beyond in chemistry, so you have to memorize these. Have fun! And so let's talk about what would iodine become when it gains 1 electron, and what would strontium become when it loses 2 electrons. So this is something basic that you have to have on a quiz or a test. So we're going to gain electrons, will become an anion. We're going to lose electrons and become a cation. So iodine is in group 7. It's going to get 1 electron. It'll become iodide, and it's an anion. Strontium is in group 2, so it's going to lose 2 electrons. It becomes strontium ion. That's a cation. So let's see how you do in the quiz. Good luck. So look at your periodic table and get that out. Pause this for a sec, and make sure you can answer this question. It's a basic question we need to know. So how many valence electrons does oxygen have? 6. It's in group 6A, so it's got 6 valence. Good. Atoms and a gain by losing valence electrons are, what do you think? Good, metals. So they're going to I would say left are losers or right are gainers. Metals are on the left side, so they're going to lose. Metals are losers. And magnesium can form a cation. How does it do that? It's in group. Go look at your periodic table. See if you can answer this by yourself. Go pause this for a second if you need. And here we go. Magnesium is going to lose 2 electrons and become Mg+2. Alright, I hope you got a lot out of this. This is a really important section. So thanks for listening. See you soon. Bye-bye.